What's up, Professor Wergeles here. We are moving on to the AudioViz lecture. We're going to look at the audio visualizer, and we're going to see how we can take the algorithms that we learned in the previous lectures, combine them, and make a complete application. Now, we're on lecture 28, so go ahead and download AudioViz before class zip. Download the zip, import it into NetBeans, and then we can begin. After loading into NetBeans, you'll see I have AudioViz during class. We're going to open up the default package, and you'll see I have a lot of files here. Now, before you proceed with this lecture, make sure you go over the media player lecture as well as the audiovisual lecture. You'll see in the audiovisual lecture, I really break down what the audio spectrum listener is. We define our own algorithms over here in the player's controller, and we specify all the inputs from the spectrum listener, see what we can do, different types of movements, changing the radius, rotating objects, changing colors. There's so much that you can do with the values given, and that's the whole purpose of this next challenge. Try to take the inputs that are given and update the user interface in a way that is aesthetically pleasing and that will show your artistic abilities. So it's very important that you go over audiovisual first, and then you come here to the AudioViz lecture. Now, if we open up the main class, you'll see this is a JavaFX FXML application where I have the start method and the stage is passed as a parameter. And I have three default visualizers here. So if I open up the visualizers, you'll see visualizer 1 implements this interface. So I have a visualizer interface, and that will be a contract. So if you want to be a visualizer, you must implement the corresponding methods in the interface. So if we open up the interface, you'll see I have four methods. I have start, end, get name, and update. Now for the challenge, you'll want to use the zip file that's provided in the challenge link. So if I go over to the challenge, you'll see there's an audioviz.zip here. Make sure you use that zip for the challenge because it is different than the zip file that we're looking at today. However, conceptually, it's the same. So make sure you use the zip file located here, and you'll see for each visualizer, I have to implement four methods. Now, the start method will be used to set up the display. So you'll be given an anchor pane by default, and you want to put your UI elements on the anchor pane so you can update the visualizer. End will remove the elements from the display. Get name will return a human readable string that is the name of your visualizer so we can show that on the display. And update will be called when the audio spectrum listener is updating. So at every assigned interval, this update method will be called, and you'll be passed timestamp, duration, magnitudes, and phases. Now, these are read-only values, so you'll want to take these values and use them in such a way to update the user interface. So that's the visualizer interface. I have four abstract methods, and you must implement these methods in order to be considered a visualizer. So if I come back to visualizer 1, you'll see I implement the interface. You must also do this for your challenge. So when you're creating your challenge, you'll start a new Java class. You'll call it whatever you want for your visualizer, and make sure you implement this interface. You'll see I have some class fields up here at the top. So here's the name of the visualizer. It's essentially the class name, just in a more human readable format. You'll see I have the number of bands, the viz pane that's passed into the start method, and I have some height and width of the display. I also have the band height and bandwidth. So some of these variables you will also use. For example, you'll probably also have a name in your visualizer, as well as the number of bands and the viz pane, and most likely you'll have the height and width of the anchor pane that's being passed. Now in this visualizer, I use ellipses. So ellipses are going to be used to make the visualizer, and you'll see I have an array of ellipses. So depending on how many number of bands is passed in as a parameter, I'm going to have the same corresponding number of ellipses. So here I start to implement those methods. So get name will be easy. Just return a human readable string of the name of the visualizer. The start method will call the end method at the beginning. Make sure you put this line of code in on your visualizer as well, because every time you switch the visualizer, or let's say you switch the number of bands, the start method will be called, and you'll want to make sure you remove the previous visualizer. So let's say I had 4 bands and I had 4 ellipses on the display. Now I changed the bands to 8. You'll want to remove the 4 ellipses and now put 8 ellipses on the display. So that's why I call end here at the beginning. And you'll see I just grab the number of bands, grab the viz pane, get the height and width of the viz pane, and then I start to figure out how to add the ellipses on the display. So I have a height and width for the ellipse, as well as creating the ellipse object. So number of bands is passed. So let's say they select 4 bands, I'll create 4 ellipses. I'm going to loop through, create each ellipse at a time, set the X and Y, set the radius, and also set the color. Then I'm going to add the ellipse to the viz pane. So I'm going to add the ellipse to the view and then add it to my array so I can keep track of those ellipses. If I don't have the array, once I add it to the view, I'm going to lose this local variable. So instead of having 8, 10, 12 hard-coded ellipses, I'll just store all those ellipses in an array. That way I can remove them from the display later. So if I scroll down, you'll see that's exactly what the end method does. If the ellipses are not null, I'm going to loop through all of them. I'm going to remove them from the display, and then I'm going to set the array equal to null. That way the garbage collection comes and then removes that object. The most important method will be the update method. Update is called at the specified interval for the Spectrum listener. So we saw an example in iTunes. So if I open up the visualizer in iTunes, you'll see some circles moving, different various shapes, different colors. That's what's going to be defined here in your update method. So I'm given the values from the Spectrum listener, which is timestamp, which will be in seconds, the duration, which will be a double value. Magnitudes is from 0 to -60, and it's an array depending on how many bands have been set. Phases is from -pi to +pi. It's also an array of floats, and the size is depending on how many number of bands are set. So as long as the ellipses are not null, I'm going to grab the minimum length between magnitudes and the ellipses. Now remember, magnitudes is not always guaranteed to have the corresponding number of bands. So let's say I specify 4 bands. It's not going to guarantee that there will be 4 magnitude values. And when I create the ellipses, I also specified based off the number of bands. So in some case, magnitudes may be greater than the number of bands. It also may be less than the number of bands. So I do not want these arrays going out of bounds. So I select the minimum value between those two and then set up my for loop. That way I don't have any arrays going out of bounds. So let's say I set the number of bands to 4, but magnitudes is 3. So instead of going all the way to 4, I'm only going to go to 3, and that way I don't get the array out of bounds exception here. Or let's say bands were set to 4, and for some odd reason 6 values comes in for magnitudes. In this case, ellipses will be equal to 4, so I'll take the minimum length, which will be equal to 4, because if I tried to loop through 5 times, the ellipses would now be out of bounds. So that's why the minimum value is specified here. And you'll see some algorithms that we talked about in the previous lecture. Now this algorithm is a little bit different. I'm going to change the radius y, so I'm going to increase the size, and you'll see I have a formula here. So I take 60 plus magnitudes. Remember, magnitudes is from 0 to -60, so it's either going to be 60 or this value is going to be 0. And I'm going to divide that by 60, multiply by half band height, plus the min ellipse radius, which was equal to 10. So I have my formula here. This took a long time to figure out how to do. You may search the web and see if you can make some cool shapes with ellipses or rectangles, depending on what you're using. You don't even have to use shapes. You could use 3D figures. And then you'll see I also set the color. So if I have 4 bands, there should be 4 ellipses. So I'm going to loop through 4 times. If I set it to 100 bands, there'll be 100 ellipses. So I need to loop through and update all of them. So at every 0.05 seconds, this update method will be called. It's going to loop through all the ellipses and update them in real time. Now this is just one visualizer. So let's try to get this one visualizer to work, and then we'll come back and look at the other 2. We're going to move over to the controller, but we're going to do that in the next video. Stick with Professor Worgles, and we'll see you in the next video.